Hello, this is Ray. Welcome to the Front-End Engineer channel and welcome to the System Design series for front-end engineers. And today we're going to take a look at one of the most common problem of the component design on front-end interviews, and this problem called data table. So we need to design the generic data table for displaying some generic data. So this data can be in any format, and our component should adapt to this data in order to display this. This component should be also highly customizable because we want actually to style this component and provide API for styling this one. So, and with that, let's continue to work on system design. And we start with, as usual, with our general system design plan. Okay, let's proceed to the design. Okay, we start with the design plan, and with the first step, we will collect the general requirements. So what actually the widget should do, what the component's functionality, what we expect from the API, and so on. So then we proceed to the functional requirements, which is actually how this widget should work on which platforms and some technical details. And then we proceed to the components architecture, where we mock up our component like the high-level view and also provide the dependency graph, which can help us understand how we later work with our data. So then we'll describe I think not the data entities, but I'd like to discuss with you the property design. So the property design is actually what the component takes as the data, input data, and how it actually works with that. And with the next one, I also would like to discuss the event API design. So for our end users, we want to provide some API in order to listen for some events. For example, we want to listen for click on some cell and get the cell data on this click and so on. Then I would like to proceed to the store design, where we actually describe how we store the input data inside the widget, and also discuss the optimization and accessibility side. I would like also to add one thing here. It's extensibility. So what is the extensibility? Is actually how we can extend our widget functionality or how we can style them in order to adapt to the user requirements. Okay, and that, let's proceed to the first step of our plan. This is the general requirements plan. So let's actually collect them. So the first step, the first thing which I'd like to write, that data table should work with the different data formats. So data table should work with different data formats. And as I see here, we can predefine some of the format which actually will be supported by default, and would be the date. This also can be a number and a string. So this is the basic data formats we need to support by default out of the box. The second thing is that the one piece of data can be custom, so we need to provide a functionality to customize the cell, so the format of the data we input. So column, so the data can be in custom format, and we need to provide API to display it and with a custom render. This means that the user defines the render function for our cell and how it actually will be displayed. So this is one thing I'd like to add here. So what is the third thing? So I think it's good to have some sorting and filtering. So let's say that we can sort by each column, and we also can configure this inside the columns. So also we can say that we can search by some query. in one more things here is dependent on the interview site. So maybe you need this, maybe you not. But I can tell that support export in CSV, but I will say this is the question, so it's not required to do that, and depending on your interviewer site. So we finished with the general requirements, and now we can proceed to the functional requirements. So what are the functional requirements? As I see here, because the data table usually works with the like thousands of rows, and we want to support many like pieces of data. So with that, I'd like to add that the data table should work perfect with the big data set. So data table should support the big data set. Okay. Also, the performance of our data table should be so our data table should work on the wide range of the devices. So you can even see that on some old mobile phones or desktops and so on. So let's say that our component supports wide range of devices. What else can we add here is that tables should be accessible for screen readers, and we should have the CSS API for styling our table. And I also add that the table and columns can be configurable. So, and under configurable, I said that you can hide some columns. You can also say that you can add sortable or not sortable columns. You can also define the name of the column. And what else can we add? And of course, the custom comparator for the column. So with all of that, with the general and functional requirements, I think we can proceed to the next step, is actually the components architecture and actually the high-level mockup of our design. So I'll create the next step. So we define the component architecture. Okay, so I have already this schema how actually our table should look like. So as you can see, there is a columns. Each column can be sorted, and there is a data. So we don't know how much columns we have in the table, so we adopt the size of the columns based on the input data we have. So I suppose, and here we see that each column can have a different type, and let's add these types actually to our support box. So we support the number, and the data cell can be the date and be in a custom format and also in a string one. And let's define the dependency graph of our components and how actually they look like on a tree. So as you can see here, we have the data table as our root component, and inside we have the header and row list. Then the header has the call header components like column 1, column 2, and then we have the row and column for each part of the row. And then, as you can see here, I emphasized the render item with a green color. So this means that render item actually can be custom and can be user-defined. And let's place the label that this is actually a user-defined. So we have our basic view on the components architecture here, and I'd like to proceed actually to the API of our components. So let's create a box with an API, and I'll copy the label here. Okay, so let's say this is the props design. I'll create a box here. I also place the text, and let's describe actually the property and entities we'd like to work in our application. So basically, we have the type data table props, and what actually takes. So it takes the input data, and it also places the generic here because we do not know what the type of data we expect here. So the data will contain just the data array. But we can be sure that actually the type is an object, so we do not work with the primitive. Okay, so then we have the data array, and I also would like to add the columns. So what is actually the column? So the columns doesn't know anything about our data. It's actually a descriptor of the columns we have in our table. It can be 2 columns, it can be 3 columns, and so on. So let's say that we have type column, and our data type props has an array of these columns as a descriptors. And because this is a descriptor, it doesn't contain any data inside, but it certainly knows about the type. It's with which type it actually works. So with that, let's actually describe the properties we'd like to see on the column, and definitely this is the name, because we want to see the name of the column. What else can we add here is we have the name, and also we can add a comparator. So what is the comparator? So comparator will be the optional property. For example, if we define, okay, I'll describe this a bit later. So we start with the type. So as we talked about earlier, we have the type string. We also can have the type number, and we also can have the type date. So with that, we have the type, and for example, if you also can have a custom type. And for example, you want to define the custom comparator in order to sort the data for the custom data type, and then here we provide this property to the column comparator. Comparator, okay. So what it actually takes 2 data entities and then return a number, like to compare them. What else can we have? As I see here, so we have a name, we have a type. We can also say that currently this column is hidden because, for example, you have like an object with the 10 fields, and you expect that for some fields actually you want to be hidden one. So you can pass this flag. By default, it's actually false, and this column becomes hidden. Also, I'd like to add the sortable property, which specifies if it's this column can be actually sorted. Okay, we have the name, we have the type, and also what I'd like to have. So imagine that we want to define the custom render function for a column, then we can provide such function. So what it actually takes, so it takes the datum of the t property, and then we return in the HTML element. So this is the render function for the column itself. Okay, we have the column array, and we have the data. What else can we add as the properties here? So actually, I think that we pretty much almost done here. Let me think a bit about it. Okay. I also think that, for example, if you have a big set of data and you want to actually enable pagination or disable pagination. We can also add such properties like pagination, which is the boolean, and this is actually an optional one because by default we expect that we have the pagination data. Okay. Let's also say that the data table has the page size property, which say how many elements we want to display in our table. So, and also I'd like to provide the custom class name in order to be able to style my component. So this is our property design, so we have all our input props, but we also can think about the API, which like event API. So what is the event API? We can subscribe for some event in our columns, such as selecting some cells or selecting or expecting the new page or something. So with that, we want to provide some event API we actually for the user. So this would be a relatively small one, I think. So event API is quite simple here. Let's say that I described it as a type. So we have the on, and on will define the subscription for the event. So, and let's describe event we can subscribe. So we define the type event data table event, and this can be cell select. Also expect that we can have row select and the page change. So this is basically like 3 main events here, and we say that event has the type of data table event here, and we need to provide actually the callback, what we are going to do with this function. What I also like to discuss here, do we need to think about the other API, for example, destroying the table or initialize it with the different properties. So let's say that we have the type data table, and we can describe this API, public API. So extends event API. So what can we have here? The first thing that comes in mind, it's a destroy. Destroy is actually just a function which destroys the HTML element. And we also can provide initialize method to enable the reinitialization of our table with some other configuration data. So, okay, as I see here, we define the whole API structure for the widget, and let's proceed to the next point here. It's actually a store design. What do we store inside our table? Okay, I'll copy this thing here and say that we have the state design. And state design is actually relatively simple, I think. So let's take some, okay, I have a predefined box here for the state, and let's define actually our state of the widget. So as a state, we see that we have the data array here, and we also need to have the filter data. So for example, we apply some filters and we want to display such data as a separate state like the filter data. Then we have the sort columns array. So basically we store the columns we'd like to, we actually sort on. So for example, we sort on the first column, and we also define the type of this sort like ascending and descending. And also we store our columns inside, and we also store the listeners which we apply to our table with our public API like on. So we also store that our table is searchable, and we store some class name and also paging and the current page. Current page is a number and also page size. And with all of that, I think we almost done here. The one thing that I'd like to also store is the elements. So elements is actually HTML elements we use for generating our row. So I don't want to actually as an array. I don't want to. I will explain it in the optimization section, but we need these elements in order to not create each time the new HTML elements. We generate the custom amount of HTML elements and then update them as the so we update them with the new data arrived. So also I'd like to have one thing here. Optionally, when we have the custom render, function, we need somehow to enable optimization for such custom render. And to enable this, we actually need to provide the update function, so we can update this custom element side. So for that thing, let's say that we can define this on the column. So I will say that it's actually update, and it takes the optional. It's optional if user doesn't provide this, then we render the whole column, unfortunately. So let's say that it takes the element we want to update and the new datum, and it returns the HTML element. And with an update function, we can efficiently update our row, even if it's a custom data format. So we are fine here. Okay, we designed the actually state, and then I'd like to discuss how we have what the data flow we have. And I'll copy the my dependency graph here and paste it here to explain how actually we are going to work with our state. Let me copy this and paste it here. So this is our dependency graph, and so we pass the data inside the state, and this data and also columns. So in order to generate header, we need to provide the header with our columns, and to generate the single column, we provide one actually column descriptor. So in order to generate the row list, we need to provide our data. And to generate a single row, we provide a single datum. And further, to generate a single column, we provide the datum column key. So what is actually the column key? In our implementation, the column key is the index. I expect that we have objects sorted by keys, and this means that we have the object has some format of data, this object, this type always have the key in the same position, and we rely on this index for simplicity's sake. We can also define the key inside the column descriptor, but this implementation will be a bit more sophisticated, and for simplicity's sake, I use the index key here. And we pass this piece of data of our single object to the render item, and render the whole item with our graph. Okay, so I actually explained our data flow and the store we have, and let's say that we proceed to the optimization side. Yeah, let's talk about the widget optimization. So what about the optimization? As usual, we have the several pillars of performance. This is the network. The next step is the rendering. And the last one is actually JavaScript. Okay, let's start with the network. Remember, we are working on the component, not the application, so we are actually quite limited in our possibility to provide an efficient networking optimization. But as I see here, the simplest thing is Xzip and Brattle our JavaScript and CSS assets. So Xzip and Brattle assets. So this is the first thing to do. I'm not going to talk about HTTP2 optimization side here because we are not working on the application side. We are working more on the just a simple component stuff. Okay, so we have the zipping assets, Brattle assets. What else can we have? One more thing is different bundles like ES5 and ES6. So we can serve our data table in different target bundles like ES6 and ES5. So the ES6 will go to the modern setups like the Chromium-based application, or when we sure that our users actually have all the polyfills and the browser support the ES6, all features of ES6. This decreases the total bundle size, and we do not need to support lots of polyfills here. And with that, yeah, we actually can optimize the network. So I also would like to mention that we need to restrict on features we work in our JavaScript. So less features we use from like ES Next, then less polyfills we'll have in our total bundle. So determine the scope of JS features. Of course, it's not relevant for the ES6 bundle, but let's say that we want to think about all users we have. Okay, what else can we improve on the network? So we can also say that make a bundle modular. What this means, so we do not want to import like the whole package. We want to import all the things only which we need. And for example, with the data table package, we can support like custom utility functions like custom comparators or custom styling themes and so on. And we can actually split this into several like modular bundles, so we do not import the whole thing. This effectively solved by the like the bundler, modern bundlers. So let's say that we want to define like core one, utility, and some theming stuff separately. So if the user wants to adjust a table, then yeah, he actually uses the core features, and if he wants some utility and theming, then he imports all this stuff. So, and we talked about the network performance. As I said, we are quite limited in the terms of the network optimization side. What else can we improve here is that we do not just zip and Brattle our assets, we can also minify them, CSS and JavaScript. And also to improve the access to our package, we want to serve this under the CDN. Okay, we have the network optimization, but this is not too interesting, I think, because the most interesting part is the rendering. And as you know, in the rendering stuff, we have the DOM performance and how we improve the DOM performance. Remember, we are working with we can work with the big set of data, like 1,000 rows, and we need to optimize it somehow. And with that, we can do several things here. First thing, we can go with the virtualization approach, and then we can go with the pagination approach. So virtualization actually maintains the constant number of elements and enables the infinity scroll, but for the data tables, I think the pagination is more appropriate because this is the sophisticated data, and we want exactly to know the page of the page to get this data. And for this design, I'll go with the pagination approach, and this actually goes to the first and the most important principle here. It's maintain constant number of nodes. So by maintaining the constant number of nodes, we optimize the DOM performance significantly. So we define the page size or we define the virtualization, but this always maintains this constant number of nodes we created. And to go even further, we can say that we reuse DOM elements via update function. So actually, how do we reuse them? So when we render them first time, we store them inside the state of our component. And remember that creating the nodes and always like appending them on a table is the very high cost operation. But updating them, their data, like smallest pieces of their data, is cheaper than removing and adding them to the DOM again. So here we provide the update function, which updates the current node with the new data, and we predefine some update functions for the sample format like numbers and date and so on. And this helps us to maintain the performance of our browser. So with that, I'd like also to mention the CSS. So regarding the CSS, it's quite simpler. We need to use use naming system. So naming system is actually what helps to name the classes. We do not want to have nested selectors because they decrease the browser performance, and we want our performance to be fast. And with that, we can if we apply the naming system, we decrease the possibility that we actually using the wrong nested selectors, which affects the performance one. Okay. CSS. Also, if we'd like to add some animations to our table, I would say that we need to prefer. The CSS animations because they're more optimized from the performance side than the JavaScript animations. Okay, what else can we have? I could say that we also can play with some user perception, and if we have some long-running data which we expect from the server, we can also say that we use placeholders. And I don't have space here, but I'll write that use placeholders. So scientific research said that if we are using the placeholders for our users and our in our application it takes a significant amount of time to load, then the placeholders can actually help us to decrease the time, not physically decrease the time, but on the perception level. So user thinks that actually the data loads faster than it actually loaded. Okay, I'll say that this is the use placeholders. Okay, we talked about the virtualization, pagination, updating the current node elements. Also, we talked about CSS. And we go to the JavaScript performance. So the JavaScript performance is important here because we're working with the data table and we support the client and server filtering. So, and with that, we need to do not block UI thread. And how we actually can block the UI thread. And this can easily be done, for example, if we're working with some large amount of data and we write the function to filter this data, and we easily can block the whole UI because in order to filter this large stuff, we need a significant amount of time. And how can we actually fix this problem? This is very easy. So we can use the web workers. This is the first step. Okay, I need to mention that we need to do stuff async. So asynchronously, so we do not block the UI thread, and we have two options. We can go with the web workers, or we can go to the server side. So basically, when we can provide the user to choose what we're actually going to do with that. But so, for example, if we user passes some asynchronous function and we know that the data is very long, it's pretty actually big one, so we use the web workers. But if it's actually server side, so if its function returns the promise, then we can expect that the user using the server side filtering, and then we just execute this function, and then when we receive the new data, we update the whole of our table. So, okay, we talked about the threads, async stuff, web workers, server-side filtering. And one thing to mention here is that we need to use the event delegation. So what is the event delegation? Remember, we provide API to set the events on our row and columns, and with that we can actually went to the problem when we have too much events settling on all elements, and how we actually maintain this problem by event delegating. So we actually listen to event on the root element. In this case, this is a data table, and then we use the custom data attributes to determine which actually cell was clicked. So in our case, here we can say that we have a row index and also the column index. So we use the row and the column index to determine which cell is clicked, and then we trigger the event, our own event, to the user and supply this event with the data we have. So this will increase we prevent the memory leak when we store too much listeners on elements, and also we prevent the case when we actually destroying the elements and then we just losing our events here. So listening on the root element is always good. So we talked about optimization side, and according to our plan, the next thing to consider is the extensibility. So I have like 2 minutes to describe this. So what about the extensibility? So extensibility is quite simple here. We want to provide we want to provide some CSS API and custom render functions to the columns, and also a capability to extend our component with like CS6 inheritance. So this is 3 points I'd like to mention. So this is the public CSS API, so the user can change it. Some render function which we use in the column, for example, to render the custom data, and also inheritance. Okay, and the next point to discuss is the accessibility, and I'll try to do that real quick. So what is the accessibility? So this is a very important thing for the data tables, because data tables are very expressive with their data. And the first thing to consider is that we need to use table tags instead of divs. And why is that? Because the table, because this is the HTML5 semantics, if we keep the semantics, this will give us many benefits like SEO optimization. So the Google engines actually are able to parse the column data and then display that as a preview in the searches. Also, this is the screen reader friendly. So we actually do not need to use many area attributes in order to provide the screen reader friendability with to our users. So the table tags actually is more like if we use the div tags, it's more agile from the layouting perspective. But I'd like to go with the user-first approach, because we need to think about the user, how they actually work with this data, and how they actually have many disabilities, and how we can provide this data even even if they have some of like these disabilities and they have to use the screen readers. So the second point, we need to enforce RAMs in our component in order to adapt to custom browser setting. So if the user has some custom browser setting, RAMs are scalable to these settings, and we ensure that our table looks well even on the like custom settings. So the other thing is the keyboard navigation. And by default, the keyboard navigation is actually enabled in our table because we are using the table, and we just need to help the screen reader and the user to navigate between rows and navigate between columns. We also can provide a shortcut for search, and shortcut for search, and shortcut for filtering. And I forgot the properties on our public API. So I also want to provide the this actually to the data table props. So I want to have the filter function here, filter func, which is by default is not defined. We use the default one, and we also sort func. Okay. So shortcut for filtering, and what else can we add? And we can use area attributes to describe the columns and cells. How can we help with that? We can use area label and area description. Okay, I think we are pretty done here. Actually, we did the whole design of the widget, and this looks good to me. Let's say that we are finished, and thank you for watching this video. You're welcome to leave the comments below and give a suggestion to the system design, and together we can make the content better. So this is Ray. Good luck on your interview and with your preparation. May the force be with you. Bye.